I welcome you back to this series on algorithms analysis and design. And in this video, we are going to take up another problem on Kruskal's algorithm. So we already know that this algorithm is used for getting the minimum cost spanning tree. So in case you want to revise the concept of minimum cost spanning tree, I suggest that you follow the video given in the I button and then you can come back to this solution. So we are given this particular graph. So we know that in this particular graph there are 8 different edge vertices labeled 1 through 8. Okay, and likewise there are 10 different edges. So all the edges they have been put in the edge set. And then what is going to be the first step? In the first step, in the step 1 of Kruskal's algorithm, what we do is we sort all these edges in increasing order of their cost. So all these edges we have sorted in increasing order of their cost, and then once this sorting is done, step 1 is complete, and then we move to step 2. So what is going to happen in step 2 is we are going to start with a forest that will not be having any edges, and then we are going to consider adding edges one by one. The thing that we have to keep in mind is that the addition of a particular edge must not lead to a cycle. Okay, so let us talk about this first edge 1 comma 2. Can I have this in this graph? Yes, I can have this in the graph because it is not leading to a cycle. What about the edge 7 comma 8? Can we have this in the graph? Yes, we can have this in the graph because it is again not leading to a cycle. What about the edge 3 comma 4? Can we have it in the graph? Yes, it is possible. Why is it possible? Because addition of this particular edge in the graph is not leading to a cycle. What about edge 5 comma 6? Again, this can be added on the same grounds. It is not leading to a cycle, right? So what I'm doing is I'm adding the edges and I'm also writing the weights next to these edges. Okay. What about 2 comma 3? Can we have this? Yes, we can have this because it is again not leading to a edge. Okay, so it is not leading to a cycle. So this edge will be there as a part of graph. What about 1 comma 3? Well, 1 comma 3 cannot be there in this particular graph because the moment I add it, it would lead to a cycle. So this edge is neglected. What about 2 comma 4? Again, addition of 2 comma 4 will lead to this cycle 2, 3, 4. So this particular edge is neglected. What about 3 comma 5? Yes, 3 comma 5 can be put in the graph because it is not leading to a cycle. Okay. What about 3 comma 6? 3 comma 6 we cannot have this in this subgraph because the moment I add 3 comma 6 it would lead to a cycle 356, right? So this particular edge is removed. It will not be a part of this subgraph. What about 5 comma 7? 5 comma 7 is an edge that can be a part of this subgraph because it is not leading to a cycle. So with this we have exhausted all different edges and now we are left with a minimum cost spanning tree. Okay, so why is it a spanning tree? Because it is having same number of vertices as in the original graph. It is connected and it is not having any cycles, right? And why is it minimum? Because in order to construct this spanning trees, we have taken edges in increasing order of their weights. So the sum total of the weights will be minimum, and that is why the graph that we have obtained is going to be called as a minimum cost spanning tree. And what would be the cost of this minimum spanning tree? It would be the summation of all the different weights. That means if I were to add these numbers, 2 plus 7 plus 4 plus 10 plus 14 plus 6 plus 3, so whatever this number comes out to be, this will be the cost of our minimum cost spanning tree, and this subgraph T is going to be the minimum cost spanning tree for the given graph G. Okay, so I hope that with this short tutorial you have fully understood the idea behind Kruskal's algorithm. However, even if you have some questions, please put it in the comment section and I will be more than happy to answer. Now this was from my end. There are some concepts that you have to study as a part of your self-study course. So the first thing that you have to study is, first thing you have to learn is the number of spanning trees possible in a connected graph with n vertices. So let's say I'm giving you a connected graph Kn which is having n different vertices. So you have to find out total number of spanning trees possible. You have to find out total spanning trees which are possible. You do not have to find out the minimum spanning tree because that is in most of the cases will only be one. In this case, you have to find out all possible spanning trees possible for this connected graph Kn. Kn basically means this graph is having n vertices. Okay. And the other thing that you have to learn by yourself is the time complexity for this particular algorithm. Okay, so these two facts I'm leaving to you as a part of self study. In case you have any questions, feel free to put it in the comments section. With this, I'm signing off in this video.